Good morning, students. Today, to proceed with your next topic of functions, that passing array to a function. I will make one program over the IDE to elaborate the concept of how you can make array using functions. In this program, you will require simple header files, hash include iostream.h and conio.h. Okay. Then a word main section, then get ch. Now we will create one function by which you can pass your array to a function. Let's take the function name as void. The name of the function is display. You can take any name here, and I will make one array here. Okay, the array type should be of integer. Name of the array could be anything. I said name of the array is a here. Then I will pass the size of an array. This is the declaration of an array in a function. Then what will be the size of elements will be there? So I will pass here two arguments. Then which type of function it will become? That is no return type, but with arguments. This will be the type of the function. No return type means I'm using here void. So there is no return type, but I am passing here two parameters. One is to declare the array, other is to declare the size of the element. Size of the element, as generally you use n here, you may use n here. I have used the variable size here. Okay. This is the function definition where I will write int I is for the iteration of loop in an array. For I equal to 0, I is less than size of an array, then I plus plus. Here I will see out the value of array of I. This is the closing of your for loop. Then I will close the function definition here. This is the same program where you simply building your array generation when you have to display the elements of an array. Okay. As you know, in the function definition, we can display the array elements. So I will write here, this is function definition. Okay. If function definition is there, then function prototype should be there. Function prototype should have the same return type. It should have the same name as name of your function. I have used the name of the function as display here. Then the number of arguments. Here I am using two arguments. First is integer, but the integer is of array type. Okay, so I will write here a, and empty parenthesis could be there, or I may pass the size, maximum size of an array here. Okay, then is int, or you may write here int size as a function prototype. This will become your function prototype of function declaration. Fine. Then is your void main section. In your void main section, you have to call the function. Here, when you look at your function is you are passing an array to a function. So when you are passing an array to a function, you have to give the value here. But when you have to give the value, You must give value by using for loop because you are using array here. So I will write here int I for the iteration of loop. Then is a10 is the maximum size of an array here. For I equal to 0, I less than, I will take maximum size is 5. You may take n here. I will make it static for the 5 elements. Then see in the value of AI. Okay. Let's save it. Compile our program. There is no any error. Firstly, we will this is like you have seen the array. Now you have to call the function here. You have to write down the name of the function as display. You have used no return type, so there is no need to write cout display. You will simply write the function display here. Then you will pass the first arguments as a element here, and the number of elements should be 5 here. This is your function call, or function calling is there. Okay. Let's compile. There is no any error. Let's run our program. Number of elements are 1, 2, 3, 4, 5 is here. 5 elements can be displayed. Now I will explain the program again. Firstly, come to the definition. In this definition, you have used one function with the name of display. You have passed one array type of argument, okay, with integer type. Okay. Then is the size of the element. You may say size of the element or the n. That will be easily understandable to you. I will use n here. Okay. You know your loop will iterate when you have to traverse your array. Here I am going to display my array. But when I have to give the input in my array, I want to give my input. To clarify the concept, I want to give my input in my word main section. And you know, if you have written your function definition after the word main, you have to write down the function prototype or function declaration. In the function declaration, you should have the same return type. Name of the function should be same. Then the number of arguments should be same. As there are 2 arguments are here, I will use here n. Or if I'm saying number of arguments should be same, and the other condition should be the type of the argument should be same. The type is data type of integer, but I'm taking here array type of function. So I have to pass here array type of variable here. Okay. You may pass here 5 or you may pass here empty. It will be automatically filled. Then in the void main section, I'm using one variable for the iteration and passing one array. I'm declaring one array here. To give the value, I have to iterate my for loop and give the scene value here. I have given the value in void main section and I'm going to display the value in my function. But if I have given the value here, you just concentrate on your void main section till here. You have input your array. Now the condition is you have to give output. You have to find out the output. The one condition is if you are using this program without any function, you will again use your for loop and instead of scene, you will write cout. But you are not going to write your for loop or cout function here. You are going to call that function where the cout function has been written. I'm calling the function display where the cout function has been written here. I am calling in the here the 2 arguments. First is with the array name, next is with the size of an array. Okay. Now I will run this. The output will be 5 elements should be there. 3, 4, 5, 6, 7 will be the answer. Okay. This is your how you can pass your array element by using the function. Okay, our next topic is inline function. The inline functions are the C++ enhancement feature to decrease control time of a program. Okay, how it will decrease the control time of a program? Generally, we say that when you call your function, when there is function calling, then the control is transferred to the function definition, then it comes back in the main program. But what happens in the inline function, that whensoever you are calling your function by making it inline function, okay, then your function definition will be get transferred there. Your program control will not be transferred to the function definition. Your function definition will be called at the function call. Okay, I will come here with an example. Function can be instructed to compiler to make them inline so that compiler can replace those function definition wherever those being called. Okay, you have to use the keyword inline when you are going to make the function inline. Inlining is only a request to a compiler, not a command. Remember this. Okay, this is very important point. You are just making a request to your compiler to make your function inline. Compiler can ignore the request for inlining. It will depend upon the compiler whether they are going to entertain the request of inlining or not. Okay. In which condition you can't apply your inline function? Compiler may not perform inlining in such circumstances. If a function, here you must consider, here it is written the compiler may not, could be possible, it may work. Okay, this is not the mandatory condition, it cannot work, it is not there, it may not work. If the function is containing a loop like for, while, do, while, if the function is containing some static variable, then your inline function won't work. If the function is recursive, that means recursion concept is there, then may be possible your inline concept may not work. If a function return type is other than void, that means if you're using int float as your return type, then could be possible your inline function may not work. If a function contains switch or go to statement, then there may be condition your inline condition may not work. Now coming to the program, how you can create your inline function. While creating your inline function, you require simple header files. I will make the function definition first. I will make one simple program here to add two numbers. As you know, this is the concept to add two numbers that we have made in our previous programs. I'm making here no return type, but with arguments. Then your void main section is there. Then clear screen. Then there is function calling. As there are two arguments, I'm making it by passing two arguments. Okay. Let's save our program, compile it. This is without inline. Fine. Okay. And the answer is 5. That means there is no error in our program. Let's make this program inline. How you will make your program inline? You will simply write your program and you will just add the keyword inline. Actually, the concept of inline is not directly visible to you. It is all that what is happening, that is at the back end of the compiler. What happening here, if you are not going to define inline, so when your void main section will run, when there is function calling, then the control will be get transferred here. Okay, in the void sum and all this thing will be get executed. But what happens when you use the keyword inline? If you say, ma'am, we're not able to see how the inline function is working, actually that is all at the back end. This is for you, this is the theoretical concept right now, but actually this happened at the back end of the compiler. But Actually, when you are going to write here inline, what happened here? Your void main section will run. Then when you are calling your function, then instead of control will transfer to here, your function definition will be get transferred here. Okay, your whole code will be get transferred here. Fine, your whole code will be get here. That means the transfer time from one place to another will be get reduced when you are going to use your function inline. Okay, this is the concept of using your inline function. Okay, so let's run this program. The answer is 5 here. That means there is no any error if you are using with the inline function, but could be possible if you are using some for loop and some switch statement, you may not be able to get the right answer. Then the reason is the inline function may work on some concepts and may not work on some concepts. Okay, now moving to the next topic. Our next topic is macro. Macro means to define identifier with predefined values or use substitute for identifier which will be replaced by predefined values. You have already used macros. Okay. Uh, when we completed the structure of C++ program, then we use the define section. Okay, that is one form of macro. That is called object macro is there. Okay, at that moment I said this is your define section. This is not your mandatory section, where we have completed one program related to how to calculate the circumference of a circle and area of a circle by taking hash define pi equal pi and value of that pi. Okay, that was the concept of macro. Let's understand in detail by programs. If I'm saying the macro is of two type, one is of object macro, other is of function macro. Let's do it one while using example over the IDE. Here you will require simple header files, your void main section, your clear screen function here. Firstly, I will write here object macro. Object macro is same as that you have used in your define section. The way to declare your object macro is hash define, take any variable as value 10. Okay. Then I'm using here int x here, and I will write here x equal to value minus 5. Okay, and cout x. This is very simple program to understand the concept of object macro. Here I'm using hash define value x. That means I'm taking one variable here and making it object macro with the value 10. Here I'm defining one variable x, and in the x there is a calculation value minus 5, where the value will be get picked. It will be picked where you have defined the value. You have defined here 10. 10 minus 5. The answer 5 will be get executed here. Let's save it and run our code. The answer is 5. If it is not visible to you, I will write here answer is, then I will run it again. Answer is 5. Okay. Now, how you can create your function macro? Okay. Here in the same program, I will make some changes. Here I am going to define the function macro. Okay. I'm saying this is function macro. In the function macro, in the define section, you will write hash define name of the function as sum here, as you know, the sum is performed among two variables or three variables. Here I will take example of two variables. What is the operation to be performed on two variables? As said, a plus b. That means when you are going to define your function macro, you will give the name of that macro, the name of the function, then the number of the variables on which operation is going to be performed, and which operation is to be performed, that you will be given here. Okay, this is your function macro. Okay. Now coming to your void main section, you are going to call that function, then you will simply write cout, then sum is. Now call the function as sum, and in this function you are passing two variable two arguments here, so you are going to give two values here, 2 and 3. Now you will run your code, just save your code and compile it. There is no any error. Sum is 5. Okay, this is your function calling. Similarly, if you are going to multiply two numbers, as you know, there is multiplication among two numbers. You can use ab as an argument, and a multiply b is the operation. Here you will change the function name as multi. Let's save it and calculate it. There is no any error. The answer is 6. This is the way by which you can create your function macro. Okay. Now coming to default arguments. A default argument is a value provided in a function declaration. Remember this, where we are providing it, provided in a function declaration that is automatically assigned by the compiler if the caller of the function does not provide a value for the arguments with the default value. Okay. First thing is, where the default value is provided, it is provided with the function declaration. At what time it will be get invoked? When you are not providing the same number of argument during the function call. When we started our programming, okay, I will take one example here. Okay, I will take the example of macro here. Here, as you know, the two arguments have been provided in a macro. That means you have to give two values here. But if you are making it default function, okay, default arguments, but you are not going to define the other value here, then by default, which value that you have given in the function declaration will be get picked. How it will be get picked? Let's do one example here. We will write simple header files here, hash include iostream and conio.h. Then I will use your function definition int x, int y, int z. Okay, here I am taking the sum of three elements of three variable x, y, z. I will use w at x plus y plus z, and as I am taking here with return type, so I am going to use the return keyword here. Okay. Now I am going to define one function declaration here. Here I will write int x, int y, int z equal to 2. Okay. Okay, let me skip this. Let's make it simple one, then I will modify it. Void main here. In the void main, you are going to call your function. This is clear screen. Then get ch. Then you are going to call your function here. when you are going to call your function, you know you are going to call your function as sum. You have to pass three parameters here because you are taking here three parameters or three arguments x, y, and z. So I am going to use here 5, 6, 7 here. Okay, the answer should be 11 plus 7 is 18. I have to display, so I'm using cout. I will write sum is for your clarification. Let's save it, compile it first. There is no any error. Let's run. The answer is 18. Our simple program is running very accurately. There is no any error. Okay. As I am passing here three arguments because this is the requirement. Let me pass two arguments here. Let's find out the error. The error is too few parameters in call. Because I have passed here three arguments, I have to give three values. That's why it's giving me some error here. Okay. If I will pass the third value, I won't get any error here. This is success condition. When I say you can give the default argument, here in Z, I will take the value as 1. Okay. And let me compile it. The answer is 13 because I have taken 5, 6, and 2. Answer is 5 plus 6 is 11 plus 2 is 13. I will take here two arguments. Earlier, when I have taken two arguments, I was getting error from the compiler that too few parameters have been passed. That means I have to pass three arguments. Now let's run this. Then there is no any error. Let's compile it. The answer is 12. Because in the default arguments, if you are giving value here in your function declaration, then if you are defining your function before, that is in the function definition, you can also give the default arguments. There is no an issue. Okay. To clarify you more, I am using it in the declaration. I'm passing here two parameters. The third value will be picked from your function prototype. Okay. Now let's change it. I will take the value of y as 2 and will give here single value as 5. Let's run this. There is no any error. The answer will be 8 because I'm passing the default arguments here. Now take over another value as x equal to 1. I'm giving sum without parameter. Let's compile it. My answer will be 4. Default arguments mean when you're not going to pass your value in the function definition, then by default, whatsoever the value that you will give will be get picked by the compiler at the runtime. Okay, this is called your default arguments concept. Now moving to your next topic. Now coming to the concept of function overloading. When the term is overloading is there, that means you are going to use the same function name more than once in your program. Okay. There must be some condition when you use the same function name in your same program. Function overloading in a C++ programming features that allows you to have more than one function having the same name but different parameter list. Okay. In the function overloading concept, your function name should be same, but their parameters should vary. Okay. As in the example, I'm using the name of the function as my function and passing here two arguments here. Then again, I'm using my function. You can skip the M here. The same function name, my function, and you will pass the three arguments here. This is compile time polymorphism. Let's run this by example that how will you perform your function overloading. I will make the changes in the same program here. Okay. Here I have made one function with void int sum and passed here 3 parameters. Okay. Then I will make a call to this function by passing 3 parameters. This is our simple program, that a function with the name of sum but with 3 arguments. Then I am passing the function in the function calling. I am passing here 3 arguments. But if I have to overload this function, then by which mean I can overload my function here is, I will write here int sum, that means name of the function is same, and passing here 2 parameters instead of 3. Now I'm passing here 2 parameters. Now I will write int w equal to x plus y. Instead of 2 or 3, I am using 2 values here. Then I will make one function prototype here with 2 parameters. Okay. This function declaration is with 2 parameters. This function definition is with 3 parameters. Means both functions are having different function declaration. This is first function calling function definition. This is your another function definition. Similarly, you can extend it. Okay, I'm taking here only 2 functions. This is function calling of your first function. Now I will use function calling for over another function. I will make here cout. Sum is sum use the value 3, 2 and 3 here. So you will find out, firstly you have written your function definition for 3 parameters. But when I am going to call the function, it is not mandatory condition that I have to call that function firstly, where I have defined the function definition firstly. So I have written the function definition, I am calling that function before, which is having 2 parameters. Okay. This is your function calling for your function. You may vary, you may call your function 1 before to your function 2. This is not a mandatory condition. When you compile your program, there is no any error. But how this program will work? When the compiler will check the function calling that there is sum and 2 parameters, then the control will be transferred to here, because the name of the function is same. But here it is required 3 arguments. Then the control will be transferred to the next definition, where the compiler will find out, yes, there are 2 arguments and it is matching with the function calling is matching with the function definition, then it will be get called. Similarly, here the function will be called at the first moment, your function definition will be get matched with the function calling, so it will be get invoked. Let's compile it and run it. Your answer is 5 and 16. Your program will work. This is your function overloading concept. Function overloading, that means you are using the same name of the function with the same type, but how it will vary with the number of arguments. You may also vary the type of the argument as float here. If I will write here 5.5, let's compile it. There is no any error, but you will get here integer type. So some linker error is there. Let's find out that linker error is there. because in declaration we are using, okay, I think int return type will work. Let me check. Okay, int will work. And in the declaration, the type varies. Here I have to change the type as float. Let's compile it. Let's run it. The answer is 5 and 16. The reason is because I am using here int w. If you will change here float w, let's run it. Then you have to change the type of your function as float. Then you have to change the type in function declaration as well. Now answer is 5 and 16.5. This wheresoever you are going to change the function type, data type, then you have to change your program accordingly. Okay, this is your function overloading. What happens if you use the same function name here as float sum, and you will pass here same number of arguments. Okay, then let's find out. Here I will firstly change the type here. Let's change it into float also. I will change the exact same functions. Now there is an error. Let's find out the error. Firstly, let's remove this by in the calling 2.5. Now compile it. Now is error. Body has been defined for function because you are using the same function's name and you are using the z is never used. Let me check. Okay, float x plus y plus z. Let's run this again. Okay. Name of the function is same. This is the main error that will encounter. Body has already been defined for the function sum. That means you have already defined your sum function. You can't with the same parameters. Body of the function means with the same parameter you have defined it. You can't define it again. Okay. Sometime you may get an error of ambiguity. Okay, if you're not encountering this type of error, then your error name should be ambiguity is there. If the term ambiguity is there, then the same meaning is you are using the same function name. That means there is duplicacy of the function, duplicacy of the number of arguments. You can't do it. Now moving to over next topic. This is the function overloading concept. Then is the structure. Structure is a collection of variables of different data types under a single name. One sort of data structure that we have covered so far is arrays. In the arrays, we have covered that you can take only the elements which are having the same data type. Same type of elements or homogeneous type of element can be taken by arrays. But if we talk about structure, then if you are going to use different variables of different data types, then you can use the concept of structure. Similarly, with the concept of classes also, here we will discuss structure. It is similar to class in that both holds a collection of data of different data types. As I told you that same as the concept of classes, the concept of structure is there. Syntax of structure is struct is the keyword, then the structure tag, name of the structure, then the member definition or member variables. Then the other way is one or two more structure variable. It may depend upon how many structure variables that you are going to take here. As example is given in front of you, that struct structure tag, that is structure name is student. You are using here two variables here. One is roll number, other is name. Roll number is of integer type, name is of string type. So I am writing here int roll number char name with the string size, then the structure variable. I am using here single variable. You may take here more than two variables. Okay. Then this is the definite example for structure. Let's implement the structures. How your simple structure will work and how your self-referential structure will work. Let's find out. This is the basic layout. Before this void main section, this is the ideal way to define your structure of class. Define your structure before the void main section and then call the member function there. Okay. So use this struct. Name of the structure is student here. Then in the structure, I'm going to define roll number. I will use a single variable. Okay. I'm not going to extend it more. And one way is I will use one structure variable as S1 here. Then I will use S1 dot roll number equal to 1. Then cout roll number is S1 dot roll number. Let's save it, compile it. There is include. Let's run the code. There is no any error. The answer is 1. Roll number is 1. Okay. You can also define your structure variable here. Firstly, you have to write down the name of the structure as student and name of the variable as S1. You can take any name of the variable. It is not mandatory that you have to give S or S1, or you can use any name of the variable. You can either define the variable here. You can take any number of the variables. It is not mandatory that you will take only a single variable. Okay. Then you will run this. Answer is same. Roll number is 1. Okay. Now coming to your presentation. This is a structure example that I have performed over the IDE. Now moving to the self-referential structure. A self-referential structure is a structure which helps one or more link pointer which point itself. As the word is self-referential, that means the thing that points to itself only. That is called self-referential. Okay. The syntax of self-referential structure is you will write the keyword struct, then the structure name, then the structure name, whatsoever the structure name that you have chosen, then the link pointer with the pointer name. This is your self-referential structure. This is the layout of your self-referential structure. Let's perform this self-referential structure over the IDE. As this is the example of your simple structure that you are taking one variable and you are displaying the value of that variable by using the structure variable. If I'm saying you are going to use the self-referential structure, then what are the changes should be there? You can take any number of variables here. Okay, here I'm taking single variable. You can take any number of variables here. You have to make up in your mind that how will you represent your node. Okay, I will show you over the board. As in your data structure, if I say this is your node 1 is here. Okay, in the node 1, if one node contains two parts, first is the data part, other is called the link part. This is our representation of node. Okay, if I say this is your node 2. Okay, again this is your data of node 2, this is your link of node 2. If I will consider node 1 firstly, let's ignore this node 2. Okay. So you are having a single node. That means any value could be there. If I am taking the value as in roll number, that means roll number will be in my data part. Then if I ask you what should be in the link part, then there should be null value. This is your node. Okay. I'm creating another node, that means taking the roll number of some another value, and I said now you have to make a linked list. You have to connect two nodes. Then what will happen in the link part of your first node? There will be the address of your second node. If I am saying this is your S1, where your S1 will contain the link of your S1 will contain the address of your S2. This is the concept of your self-referential structure. Similarly, you may extend it. And if I say what will be in your node 2 link part, only two nodes are there will be null. Then the concept will change. In the S1, if I say in the S1 data is 20, in the S1 link part, there is address of S2. If I say S2 data is 30, if I say S2 in the link part, there is null value. When you are going to implement your program, you will write null instead of 0 or anything. The null will be recognized by the compiler. You will write null. This is your self-referential structure. Okay, I am writing here link because in the structure, as I have told you, in the structure you can use your struct as a keyword. Then the name of the structure is, let's take it as the name of linked list. Then I said in roll number is there, then name of the structure is linked is there, and the pointer variable I will take as link. Whatsoever will be the name of your pointer variable, your self-referential variable, you will take the same name as there. Okay, if I'm taking here star p, then you will use here s1 dot p will contain. Okay, this is just the name of the variable. It is not mandatory that you must write link. For my reference, I am writing here link so that it can be easily understandable to you. Okay, I will make one program of self-referential structure. Here, I'm using simple header files. One variable says roll number. I will use struct as a keyword, and you may either write struct or you may skip struct. Then link as self-referential structure. This is your self-referential structure. Fine. Now is your void main section. Let's call two variables here, student S1 and S2 as structure variables. In the S1, it will contain the roll number S1. In the S2, it will contain the roll number S2. Okay, these are two values that I have assigned here. Similarly, what the S1 will contain, S1 dot link will contain the address of S2. How it will contain it, that I have shown you. And S2 link will contain the null value. If I say you have to display the value of S1 roll number, then I said here I will write S1 roll number in the same line. Okay, I will use a different line here. Cout S2 roll number is S2 dot roll number. Let's compile it. S1 dot S2 dot data S1 dot link. Okay, will come here. S1 dot okay. Here I'm using as student. Statement missing. Let's compile it. There is no any error. The roll number one is S1 roll number is 1, S2 roll number is 2. Let's find out. It's in the linking part. You will get different values here. If I say display the value of S1 dot link and display the value of S2 dot link. Here you will get the addresses. Here you can find out in the S1 the value of 1 is stored at some address, the value of 2 is stored at some other address. But there is a linkage that by using the S1 you can access the S2. Similarly, if I say, as I am saying you can use the linkage, how can you prove it? Use the cout. Roll number is S1 dot link is assigning to the roll number. Then I will run this. The roll number is 2. Okay, I will clarify you. If I run this, firstly, you must look at this line very clearly. There is roll number is whatsoever is in the link of S1. What should be in the link of S1? I said address of S2. In the address of S2, there is data of S2. The S2 data is 2. That means by using the linking part of S1, I can access the roll number of S2. The roll number is 2. By using different variables, I can access the value in a structure. By these two lines, you can find out the value of S1, you can find out the value of S2. Okay. But if I say by using the linking part of S1, you can access the other node. S1 is only linked by one link variable, that is pointer variable, self-referential variable, which is containing the address of S2. By this, you can access the S2 node. That is, one node is connecting to the another node. This is the example by which you can prove it. Okay.